Good evening. Welcome to the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. My name is Leon Jones, and tonight's presentation, I'm going to talk about the field of industrial engineering. Now, if any of you all understand engineering, the science of engineering came from biology, physics, and chemistry. But there are four main branches of engineering, and they are chemical, civil, electrical, and mechanical engineering. Now, where does industrial engineering fit in? Well, industrial engineering is a breakoff of mechanical engineering. But that still doesn't answer the question regarding industrial engineering. So I'm going to give you a definition, and then we'll go into a little more in depth about industrial engineering so you can understand what this major is all about. And some of you may be interested in industrial engineering. First of all, industrial engineering is an engineering profession that is concerned with the organization of complex processes, systems, or organizations by developing, improving, and implementing integrated systems of people, money, knowledge, information, equipment, energy, and materials. Industrial engineers use specialized knowledge and skills in mathematical, physical, and social sciences together with the principles and methods of engineering analysis and design to specify, predict, and evaluate the results obtained from systems and processes. From these results, they are able to create new systems, processes, or situations for the useful coordination of labor, materials, and machines, and also improve the quality and productivity of systems, whether they are physical or social, depending on the subspecialties involved. Now, as you know, industrial engineering may also overlap with operations research, systems engineering, manufacturing engineering, production engineering, supply chain engineering, management science, management engineering or engineering management, financial engineering, ergonomics or human factors engineering, safety engineering, or others, depending on the viewpoint or motives of the user. Now, based on what I just told you, industrial engineering is an interface between engineering and business. Now, the origins of industrial engineering all stem from the Industrial Revolution. Now, there is a general consensus amongst historians that the roots of the industrial engineering profession date back to Industrial Revolution. Now, the technologies that help mechanize traditional manual operations in the textile industry include the flying shuffle, the spinning jenny, and perhaps most importantly, the steam engine which generated economics or economies of scale that made mass production in centralized location or locations attractive for the first time. So the concept of the production system had its genesis in the factories created by these innovations. Now, the specialties of labor, Adam Smith's concepts of division of labor, and the invisible hand of capitalism introduced in his treatise, The Wealth of Nations, motivated many of the technological innovators of the Industrial Revolution to establish and implement factory systems. Now, the efforts of James Watt and Matthew Boulton led to the first integrated machine manufacturing facility in the world, including the implementation of concepts such as cost control systems to reduce waste and increase productivity, and the institution of skills training for craftsmen. Now, Charles Babbage became associated with industrial engineering because of the concepts he introduced in his book on the economy of machinery and manufacturers, which he wrote as a result of his visits to factories in England and the United States in the early 1800s. The book includes subjects such as the time required to perform a specific task, the efforts, or let's make a correction, the effects of subdividing tasks into smaller and less detailed elements, and the advantages to be gained from repetitive tasks. Now, when it comes to interchangeable parts, these names you may be familiar with. Eli Whitney and Simeon North proved the feasibility of the notion of interchangeable parts in the manufacture of muskets and pistols for the U.S. government. Now, under this system, individual parts were mass produced to tolerance to enable their use in any finished product. The result was a significant reduction in the need for skill from specialized workers, which eventually led to the industrial environment to be studied later. Now, of course, you had other aspects, and other aspects, I'm talking about manufacturing, machinery, human factors, cost. And if you listen to what I just said, some of these coincide with manufacturing engineering and mechanical engineering. Again, mechanical engineering is one of the oldest branches of engineering, and industrial engineering, from my standpoint, is a breakoff of mechanical engineering. Now, when it comes to other engineering disciplines, one must understand that engineering is traditionally decompositional. To understand as a whole, it is broken into parts. One then masters the parts and puts them back together, becoming the master of the whole. Industrial and systems engineer, their approach is totally opposite. Why? Because any one part cannot be understood without the context of the whole. Changes in one part affect the whole, and the role of a part is a projection of a whole. Now, in traditional engineering, people understand the parts first, then they can understand the whole. But when it comes to industrial engineering or systems engineering, they understand the whole first, and then they can understand the role of each part. Also, industrial engineering considers the human factor and its relation to the technical aspect of the situation and the all of other factors that influence the entire situation, while other engineering disciplines focus on the design of inanimate objects. See, industrial engineers integrate combinations of people, information, materials, and equipment that produce innovative and efficient organizations. In addition to manufacturing, industrial engineers work and consult in every industry, including hospitals, communications, e-commerce, entertainment, government, finance, food, pharmaceuticals, semiconductors, sports, insurance, engineering, accounting, banking, travel, and transportation. You see, industrial engineering is the branch of engineering most closely related to human resources, in that industrial engineers apply social skills to work with all types of employees, from engineers to salespeople to top management. One of the main focuses of an industrial engineer is to improve the working environments of people, not to change the worker, but to change the workplace. Now, all engineers, including industrial engineers, take mathematics through calculus and differential equations. However, industrial engineering is different in that it is based on discrete variable math, whereas other engineering fields, they're basically concerned on continuous variable math. So the industrial engineers they use a lot of linear algebra and differential equations as opposed to the use of differential equations, which are so prevalent in other engineering disciplines. This emphasis becomes evident in optimization or production systems in which industrial engineers are sequencing orders, scheduling batches, determining the number of material handling units, arranging factory layouts, and finding sequences of motions, and etc. Lastly, to understand this, industrial engineers deal almost exclusively with systems of discrete components. Now, as with every other engineering, there are subdisciplines. So the subdisciplines of industrial engineering, and there are pretty huge. There's facilities engineering and engineering management, financial engineering, energy engineering, human factors and safety engineering, information systems engineering and management, manufacturing engineering, operations engineering and management, operations research and optimization, policy planning, production engineering, quality and reliability engineering, supply chain management engineering and logistics, or just supply chain management, systems analysis, systems engineering, related disciplines like organizational development and change management, and behavioral economics. Now, again, when it comes to industrial engineering integrates engineering and business, and industrial engineers deal with improving the workplace, not the product. So, when it comes to industrial engineering, you must understand this, that industrial engineers study the interaction of human beings with machines, materials, information, procedures, and environments in such developments and in designing a technological systems. Now, of course, just like every other engineering branch, colleges offer degrees in engineering and engineering technology. So, again, when it comes to industrial engineering, the same requirements for every other engineer is prevalent. If you want to get licensing, you must take the fundamentals of engineering examination and pass that. Then you can take your PE examination. Now, some may ask, well, what's the difference between industrial engineering and engineering management? Well, if you think about it, engineering management is a subdiscipline of industrial engineering. So, again, if you're interested in industrial engineering, look at the curriculum and find the proper university that has the program. Now, make sure the program is accredited by ABET. ABET stands for the Accreditation Board for Engineering and Technology, because if it's not, you're not going to be able to take your licensing exam right away. Now, you can still take your licensing exam, but you're going to have longer work experience. Instead of 4, some states require 8 and even 12, particularly when your program is not accredited by ABET. But again, at the end of the day, when it comes to industrial engineering studies the interaction of human beings with machines, materials, information, procedures, and environments in such developments and in designing a technological system. Now, industrial engineers are involved with improving the workplace, because once you improve the workplace, it's up to the organization to change its policies. But when it comes to industrial engineering is about interaction with human beings when it comes to information, procedures, environments, machines, and also involved with industrial engineering, there's system engineering. There's system. Whereas other engineers break everything down in components and then they get the whole part, industrial engineers always study the whole and then they go back and look at the parts. But regardless, industrial engineering is a pretty broad field. Again, if you're interested, check out your local colleges and universities. That's all I have. But if you like what I just presented, please comment, share, and subscribe. I'm going to be producing other videos, so stay tuned. But in the meantime, that concludes this video of the Mind of STEM channel. Again, if you cannot find any of my videos on YouTube, check me out on Facebook and Twitter. Because remember, the Mind of STEM is where you get your daily dose of science, technology, engineering, and math. Thank you for viewing this video. I want you all to have a good night. And once again, my name is Leon Jones. Till next time, be safe and God bless you.